Hello, this video is about the Series Baseboard Simulator, which is part of the Hydronics Design Studio 3.0. The purpose of this particular module is to simulate and analyze as well as design of a hydronic series baseboard circuit. We have a graphical representation of what the circuit will look like, and each one of these orangish controls will get into other windows, as you'll see in a minute, for specifying the details of the circuit. Within that, we have manufacturer's database. We have 52 baseboards. We have over 400 different circulators and another 75 of the newer multi-mode circulators to select from. You can also select different pipe sizes as well as different fluids, all based on manufacturer's database. Let's get into some of the details. This is the initial start screen that you've seen on all the modules if you've looked at some of the other videos. I'll pick the Series Baseboard Simulator, and comes into this package basically with, you can have multiple zones, up to 10 zones, and then in each zone you can have 1 to 12 rooms. And in each room, the baseboard is represented here. I can change the number of rooms. Let's say we want 3, and now 3 appear. So this basically has a total baseboard in each of these rooms. The interface here is somewhat graphical, as you can see, as well as we have very powerful windows we can open up to do any kind of specifications of the system. In terms of the baseboard, you can open up the baseboard data, and from that you can see it has the room name, which you can change, as well as you have a list of baseboards you can pick from. One thing you have to be aware of is that each one of the baseboards has a certain size pipe size that goes with it, and that needs to correspond to the piping size that's designated on the system. Now I'll keep it at 3/4 inch. I'll pick a 3/4 inch baseboard here, and then I'll leave the load alone. This is the load on the room that the baseboard will, the length of baseboard that it calculates will come very close to this design load. So I'll accept it, and as you can see, it says on this particular one, room 1, I need 7 feet of baseboard based on this particular circulator at this particular inlet temperature, with any piping that is in the system piping, type of fluid, and all that. So let me go up to a 50% glycol. You can see it tells you, gives you some output in terms of the system, as well as it tells you your flow rate coming through the system. It does all the fluid dynamics calculations as well as the heat transfer calculations for the series baseboard system. I'd like to show you the circulator interface. Here's where the circulators are, and you can do a pull down, and we have over 400 different manufacturers circulators, and all the information in terms of the circulator performance curve is all in the math of this program. I'll pick a Grumpus 1 speed 1. It gives you the flow rate for this particular circulator, and we can also go into the piping, and you can, the default is 3/4 inch. I will show you that we'll come up with a warning if I change this to 1 inch and then hit accept. It gives me a little note here that says, hey, the pipe size in the circuit is not equal to the baseboard pipe size. So you can correct that, or you can leave it as that, but it'll keep giving you that particular warning. But it did choose 1 inch, even though the baseboards here are 3/4 inch. And again, it gives you the warning. So I'll go back and I'll change my piping to, and it goes very quick, as you can see. I changed it to 3/4 inch. If you want to go back into the piping, you can change the length of the tubing, number of elbows, all the different types of valves, couplings, reducer couplings, and flow check valves. So you can change any of these, the numbers here, and it does the calculations for that size of pipe for those particular fittings or valves. And let me put in 3 there, and let me put a couple ball valves in too. Okay, I return, and now it's giving me a warning here because it's saying that the velocities are too high. I'll close that warning off. There's a few warnings that the system will give you, just to make sure you're in check here. And then I'll go back, and probably that pump is a little bit too big. I'll reduce that pump, and as you can see, it gave me a lot less flow. I could even reduce that more depending on which circulator you want to go with. I'll go back to the 20, gives you 3.3 GPM. As you can see, the calculations are almost instantaneous. Now the system also has a multi-mode circulator database, which I'll check this. It automatically goes to this particular one, and it's giving me again a warning on that it's too big for that. But here's your list of 75 different multi-mode circulators. Let me pick, it's still a little bit too high for this system. I'm getting high velocities and 5.1 feet per second. There, we got one that brought it down to 5.55 gallons per minute. Also, if I had more piping or whatever on there, it would also bring that flow rate down. So you can either go with the multi-mode. It has capabilities of either going with multi-mode circulators, or if I take that check off, now I have the standard type circulators. As I mentioned earlier, you have the capabilities of having multiple zones. A zone is this whole system connected to the same boiler, of course, but that would be the circulator and any of the baseboards as well as the piping. If I go with multiple zones, let's say I've got 3 zones. Now this happens to be zone 1, and it says it right here, zone 1. If I go to zone 2, the default there will be 1 baseboard, and there's a default in terms of the baseboard, the baseboard that is the default baseboard. Now we can get into this later here, but you can actually use the same settings here on all of the different rooms. I'll just return this and go back again. So this would be zone 2, and then if we wanted to go to zone 3, looks very similar, right? Zone 3, same circulator. Well, let me change the circulator in zone 3. So let me go with I know this wouldn't be typical, but just to give you a demonstration, let me go with a bell and gusset. So I went with a bell and gusset in zone 3, and let's put on more rooms in zone 3. Let's say there's 7 rooms. So again, it does the calculations for the 7 rooms with all the defaults in terms of the baseboards. We can go in each one of these rooms and change the baseboard data, as well as we can change, as you can see, we changed the circulator, and we can also go in and change the piping lengths and some of the valving. I'll hit return, okay, accept it. So this is in zone 3. I can go back to zone 2, which had 1 baseboard. I can go back to zone 1, which had 3 baseboards or 3 rooms in it. And now, as you can see, this is the Armstrong 25. If I go to zone 2, it's the Armstrong 20. And if I go to zone 3, I have the bell and gusset. So it keeps track of which circulator is in which zone, as well as number of baseboards and all that. Another interesting thing this program does is it designs the length of baseboard for that particular load in that room based on the incoming temperature. And then, as you can see, as you go along here, the temperature is dropping from 180, 177 to take out the, I think it's 5,000 BTUs per hour, and then it comes down to 175 and so forth. And you'll see by the time it gets to room 4, the temperature has dropped to 173 degrees, and now it takes a little bit more baseboard to put out that same amount of heat, and so forth, all the way down to here, where the temperature is down to 167, and the amount of baseboard needed for that particular load here, which happens to be 5,000, is now 12 feet. So it keeps track of the temperature drop and then designs the baseboard length based on the flow rate going through as well as the temperature in, and it calculates the temperature out. One thing to note here, this gives you the output in terms of results, is this is the output for this particular circuit. If I go to a different zone, let's say zone 1, right, this is the output or the heat load on this particular circuit here. This is the total on the boiler icon here. This is the total load of all four zones I have in there now. Zone 2 tells you what zone you're in. Zone 2 also says there's only 5,000 BTUs per hour on this particular one, and it gives you the circuit temperature drop and the total baseboards in that circuit. One more additional feature I wanted to show you. If you go into any of the baseboard data windows, there's this big control here that if you click on it, it will use the model selected for the baseboard in all other rooms in this zone. If you click on this one, it will put these baseboards in all other rooms in the system. That means all the different zones. So this one's for this particular zone, all the rooms in this zone. This is for all the rooms in all the zones of this system. So let me change this just to show you. I'll go with the crown, it's 3/4 inch, and I'll pick this. And it says, are you sure you really want to use all the baseboards selected in the first room of this zone for all the other rooms in this zone? And I'll say yes, and then I'll hit accept. And now let me go to any one of these other rooms, and you can see they have the same baseboard in them. Now if I go to a different zone, let me go to zone 2, and we go there, it's still the American design heat. So it's not all the other ones. Now if I go back and I say okay, let me go back to the zone 1, that still also has the same American. And if I go to zone 3, that has all the Crown C8s in it. Now if I pick this one, it says do you want to put it in all the zones? In other words, that baseboard will go into all the zones, which is typical, right? So I'll hit accept, and now I'll go to any of the other zones. Let's say zone 1, and if I go into there, you can see the crown has gotten inserted in there. It's just a quick, convenient way of doing it, of assigning the same baseboard to all the different rooms, either in a zone or in all the zones. I think that's about it. I'll conclude this video on the Series Baseboard Simulator, which is one of the modules and part of the Hydronics Design Studio 3.0. Thank you.